Given here, we have exponential function and a composite function, which is non-function. So for the first question, find the domain and range for the function fx. So for domain, DSLR. So for this function, notice that this is exponential function, so that is not our special function that we need to calculate. Therefore, for domain, we can directly state domain for this function is just common negative infinity to infinity. Meanwhile, for range, for the function, range, we're going to remember Kasra. So for range, so exponential is our special function in calculating range. So how we're going to calculate this range, we're going to close this exponential. As we close this exponential, we can notice that this exponential is positive infinity, positive function. So it not it will denoted as positive infinity. It will give you hints infinity positively. So you can see the value outside here is 3. So 3 up to positive infinity, not included because exponential function it has is asymptote, horizontal asymptote. So that will be our domain and range. Then we have to find the function of gx from this composite function. So given the composite function, g of x is equals to 1 over 2 ln e negative 2x plus 2. So function fx, we have to substitute this g e to the power of negative 2x plus 3. So notice that our function g is mapping on a exponential function. What we need is the g is mapping for value x only. So therefore, in this case, we're going to let m equals to e negative of 2x plus 3. So from here, we can do a new mapping where g map for m is equals to, so what can we substitute here? We can see 1 over 2 ln e to x plus 3. So it will be equals to m minus 1. So here to get e negative 2x plus 2. So now we can mapping back this g back to x. So it will be 1 over 2 ln x minus 2. So if you not really understand here, because I want to substitute m into this function, this represented by m. So how do I get m? So for e negative 2x plus 2m plus 1, it will be equivalent to our m. So e negative 2x plus 2, it will give you m minus 1. Because n is plus 3, so plus 2 and plus 1 equals to n. So if you want only plus 2, so it will stand for n minus 1. So this is how we get our gx. Then find the inverse and sketch the function of the gx and its inverse on the same axis. So to find its inverse, we will use the concept of g inverse equals to x. So the function mapping back to its inverse, you get x. So substitute g inverse into the function of g. So it will give you 1 over 2 ln here g inverse minus 1. So simplify until you can get g inverse. So 1 over 2 move to the right hand side. You get 2x. Then unlock this. So the base e will go for opposite, then the 2x will become power. Then finally we simplify for the minus 1. So it will become plus 1. This is our G inverse. Then lastly, we have to sketch this graph. In order to sketch function of gx and G inverse, we need our axis of reflection, which is y equals to x. So we're going to sketch function of g, then reflect to get the inverse function graph. So log function. What is the domain for this log function in order to draw out the graph? So for log DSLR, so apa yang log bawah iaitu x minus 1, it have be greater than 0, so x have to be greater than 1. So therefore, on x equals to 1, it will be starting its asymptote. So log adalah bentuk tiang lampu. So asymptote dah dapat, tiang lampu whether going to the right or going to the left. As we can see, domain greater than 1 means kita punya shape of the graph tiang lampu is going to the right. So terbalik ke tak? No, because this log function you can see coefficient here is positive. So tiang lampu ni akan tetap menegak. Then we can draw our log function. So this is our gx. Notice that we have intercept here. So to find this intercept, it is y equals to 0. So 1 over 2 ln x minus 1 equals to 0. So we find out what is the x-intercept. So times 2 is to get 0, unlog e to the power of 0. So you will get 2. So after we done the function of gx, then only we reflect using the reflection axis to get G inverse graph. So vertical asymptote, when it reflect, you can get a horizontal asymptote right on this point. So the horizontal asymptote now become value of 1. And then this log function, we will reflect symmetrically. So this is our G inverse. So label our graph clearly. Horizontal asymptote y equals to 1. Vertical asymptote x equals to 1. Intercept value of 2. Origin 0. So x-axis, y-axis, axis of symmetry, function, so everything complete. Then we're going to see how we're going to score this. So for the first part, stating the domain, so it's just a basic 1 marks. And then finding the range, so it need a bit of concept in order how to read the value. So this is your final answer. Then to find function of gx, the first one, we substitute our function of fx here, the first concept. Then we're going to substitute to get in terms of m correctly. So finally simplify to get in terms of x. Then in order to find G inverse, so this is the concept, G inverse equals to X. Then simplify this to get G inverse and answer. So for the graphing here, we are going to look on the shape of function gx, where shape must be correct with the asymptote with the labeling 1, 2. Then only we can accept your inverse function correctly. Then lastly, for another marks for this figure is everything is labeled completely, including refraction axis, then y axis, x axis label.